Philip, thanks for the talk. As you know, I'm quite supportive of this. I guess I mostly have a few questions about whether your distinctions and your way of distinguishing the different patches maybe break down in the limit. So one thing that I'm worried about is sort of the relationship between specificity and being cognitive or non-cognitive in a function. So let's say you believe that even more traditionally cognitive brain areas are multifunctional. If you believe that, then there's not going to be a very specific relationship between the activity of the area and a given cognitive function. There's going to have to be some broader network context that mediates that area's activity so that it becomes specific for a particular cognitive function.
Right.
Similarly, if we just look at one function, it's not as though an area is sort of somehow sufficient for that function. Even perceptual areas have to feed forward to parietal areas and frontal areas that are in charge of perceptual judgment. So on the one hand, I'm a little worried that the specific versus non-specific distinction won't do the work that you want it to do in picking out the cognitive versus non-cognitive function distinction. So that's one worry I have. Another worry is about sort of, I think there's some borderline cases here with the cognitive and non-cognitive. So you point out how whisking behavior and the CPGs in, I guess it's barrel cortex, is that where those are?
Yeah.
Are non-specific for behavior.
It's not cortex, it's in the subcortex, the CPG for whisking.
Okay. Well, wherever it is. So you point out that this is sort of non-specific for particular social behaviors and so forth. But to be kind of glib about it, seeing is pretty non-specific for a lot of behaviors, right? Because I can see all kinds of different things and I can like perform all kinds of behaviors about them or in regards to them. So I mean, even though I'm generally very friendly to the picture, I just wonder if there's maybe a little more work to do sort of on the margins of some of these distinctions.
Yeah, thanks. Okay, so the first thing that I want to say about specificity is so I don't make like a claim that there needs to be like a mapping from area cognitive function, right? So whatever the actual entities are that are operative in the cognitive function, those sets of entities and activities within those entities or of those entities should be specific, should have specific effect on the output. So it might be that one area is not sufficient that of these other areas or networks. But I think that doesn't make a difference to the claim of saying that however those areas are involved in a cognitive task differs from how, let's say, the breathing center, the brain center is involved in that cognitive function. So it's always about the comparative case, right? It's not the case that in general, it's not like that all specificity is a relational property. So of course, like a non-cognitive structure is causally specific to its non-cognitive output, but it's less causally specific to a cognitive output than the corresponding cognitive structure. So that's the idea. And so I think that survives this sort of problem that you might have like less extent of specificity because of multifunctionality. Because you say, well, even if that's the case, if we compare them, then we get less specificity in the cognitive structure. So that's what I would say right now about the first point. And then the second point was that you said, okay, with this example, it seems like we could extrude a similar case with perceptual area, right? Right, various perceptual tasks. And I guess to a certain extent that's true. I think the point that I was trying to make is that if you look at the relationship between the cortical area, like barrel cortex, right, which is the sensory area, then the brissa motor cortex, which is the output, which generates this whisking or which not doesn't generate but modulates the whisking output because the output is generated by the central pattern generator. That relationship that is sort of non-specific. If these authors are correct that there is this sort of inhibitory connection and it's just more like a gate, then it seems like the central pattern generator generates the whisking frequency, and it just does that. What it does given endogenous modulators, and then there is this sort of like task-specific modulation. But then it seems like that the whisking generator sort of has more still the sort of role in behaviors, whereas there is this exactly this contextual variation that you described in your account in these cortical areas. Does that sort of answer?
Yeah, it's helpful. I mean, so let me give one more example, and then I'll cede the floor. I mean, even if we stick in purely cognitive areas, right, or purely cognitive. So let's say I want a beer, right? And there's 3 different kinds of beer in my fridge. There's a less specific relationship between my general, I mean, I hate this language in general, but there's a less specific relationship between my general desire for a beer and the specific thing that I do when I, reach out and choose a particular beer, right? So the word is just that these even when you switch to this kind of comparative way of talking, there are always going to be more and less specific relationships between different functional parts of a process. And that maybe that won't make exactly the same distinction because we can get the same kind of relationships. Now you might say, maybe you bring in the sensory thing or here or something like that, but I'm still not totally convinced that the more versus less specific is gonna do it for you. Although I see how you're putting it in these cases, and
right.
So anyway, I'll think more about it. I don't want to take everyone else's time for the time being.
Cool. Okay. Yeah. One thing that I wanted to say to this, what just came to mind is, of course, like I use causal specificity, right, only as evidence for these operative conditions or enabling conditions. So you might have other types of evidence. So for instance, Colin Klein has the notion of systematicity, that there is a systematic relationship between the brain area and this cognitive output, right? So you could have like further evidence to try and distinguish that. I just focused on that to like sort of get this distinction going, and then maybe you might have to add further criteria to sort out these other cases. Because you could say, right, there's a systematic relationship between your desire to want a beer and these different types of beer that you're grabbing, but perhaps there isn't if you look at your breathing rates that are involved when you're going to the fridge and while grabbing the beer.
Yeah, thanks, Philip. Really interesting talk. I'm also quite sympathetic to the overall picture, I think, particularly the idea that we might need to focus on some non-cognitive or at least differently defined kinds of functions in order to understand what's going on in the brain. Like Dan, I guess I share this concern about exactly how we distinguish these functions in different contexts and so on, what counts as cognitive and non-cognitive. My question isn't really so much a question as just a particular case. So you focus on gain control as an example of infrastructural function, which I found very interesting. But I was just wondering about so it seems quite popular in some cases anyway to use gain control or some kind of gain control as part of an explanation of attention or attentional mechanisms, particularly in predictive processing and Bayesian accounts more recently. And this seems to be, I guess, a cognitive function, although if there's something like attention modulation going on in all kinds of visual processing or all kind of sensory processing, maybe it wouldn't be, maybe it would be non-cognitive. So I was just wondering what you thought about that particular case.
Yeah, thanks, Joe. That's an excellent question, which I actually get quite often. So first, I would say what I said in the end, right, with these modulatory functions, that I think attention might be more this in-between category because it affects like all kinds of different things that you're doing. So it's like, or cognitive scientists, I guess, would say it's domain general, right? But that might be that it's like in terms of the output that the cognitive system is producing has more this modulatory role. So there I agree with you. With the question of gain control, I think again, also the concept of gain control there has sort of different meanings. So I think when people talk about controlling gain and attention, they, as far as I know, talk about global gain of the system, where this is very locally defined gain. And it's sort of this doesn't really this control of gain is sort of on the system itself, rather than, for instance, you might say that V5 modulates V1, right, in attention, and that's the sort of gain control type of behavior. That's more of a global type of gain, and then you could argue, but both in V5 and V1 there will be local circuits that have to control that gain not to overexcite. So I think these different types of gain, or whatever you might call them, would also coexist, because even that cognitive gain controller needs to not go into epileptic seizure, and so this function would be still required. But you're definitely right that one needs to sort of carefully distinguish these cases. It's also something that I want to sort of look into further, and I think would be really interesting. So thanks, that's a great question.
Really enjoyed the talk, Philip. I had one comment and then one question. Mm-hmm. So the comment coming from Dan's question and Joseph's question is there seems to be two ways in which the notion of causal specificity is being invoked. So in one case, you're saying that there's a neural structure might be involved in cognition that's non-specific to particular information that's being processed. So you could have a part of the visual system that's needed to sort of support the visual system, but does not care about whether a tree or a flower is being presented. It's not part of processing those sorts of different things. But that's a different thing than saying that there's a process. So in that case, right, you might have like an infrastructural element that really supports a single cognitive process, but isn't involved in, isn't specific to the different kinds of information that's going on in that. Whereas you could have, and the medulla and breathing would be, the canonical case, but you could have a infrastructure that supports many different, an infrastructural process that supports many different, that's non-specific to different cognitive processes, right? And so I think, the idea of causal, in one case, causal specificity seems relative to the information being processed by a single cognitive system, and in another case seems to be how many different cognitive functions or systems it supports. And so, anyway, that's just a comment that there might be something to distinguish those. My question is actually about sort of the charge of cognitive myopia and how you want to make good on it. So it reminds me a bit of, like Gould's idea of pan-adaptationism or something like that. General, scientists have this persistent bias. So my question about cognitive myopia, so I'm convinced of your cases of neglect, where there are things that we just aren't looking at, and tossing out really resting state data is a really good example. But I'm curious if, in addition to neglect, there are concrete examples of misunderstanding. So, are there cases where there are features of a neural circuit that people just consistently tried to think of as cognitive, but in fact are infrastructural or architectural? So yeah, I'm just kind of curious if you can think of good examples of misunderstanding in addition.
So with misunderstanding, I think, so one thing, just so how I sort of, what I take as signs of cognitive myopia is that in many discussions, the discussion goes kind of like, is this noise or is it functional? right? Like you measure some sort of feature of the neural system, like some oscillation or something, right? And then it's noise or it's functional. And then sort of when people say show that it's functional, oftentimes, almost all the times in these cases that I looked at through showing that it somehow plays a role in cognition. So it's kind of like, if at least implicitly, these people assume if it's functional, it must play this role in cognition. So that's sort of what I mean by this tendency, just to make this clear. And that's what I also noticed, like either in written debates, but also in discussions. Concrete cases of misunderstanding, I think so. I mean, for instance, with the central pattern generators that I mentioned at the end, right? This sort of idea that, I mean, it's not like we have yet to discover actually whether there are real central pattern generators in the cortex. That's like extremely difficult to actually and also empirically establish, because these circuits in the cortex are way more complicated than the small circuits that you looked at. But the sort of assumptions that what we need to be looking for are circuits that play a role in learning or memory, whereas in fact you might find some sort of generator, some pacemaker, and it's there to like sort of, you know, keep the system going or maintaining some sort of status quo. That's where I see the sort of risk. The other thing, yeah, I mean, if you want to, I don't know if I said, did I say actually that there are concrete cases of misunderstanding? I think like my characterization was more like neglect is kind of like you just don't talk about it, right? Or it's just not on your radar. And then I had this more negative evaluation where you throw it out as noise or as epiphenomenon. So these papers on oscillations where they say, oh, we can find a consistent relationship to visual stimulation. So these oscillations might just be like an epiphenomenon that doesn't play a role. So for me, that's at least a misconstrual of what these oscillations could be good for. If they are part of this infrastructural function, it's wrong to say that they are epiphenomenon, even if it turns out that they don't have a role in information processing. So that for me is already like some sort of misconstrual of their role, right? That you throw them out as epiphenomenon. I don't know. I don't think I've ever said or wanted to say that there's like, look at these cases where people like are completely misunderstanding what the system is doing.
Yeah. And I'll cede the floor. So I think that's great. But I was just curious whether, you know, people could reply like, oh yeah, of course we all know that the brain does things that aren't, you know, cognitive, and of course we all know that there are processes that have to keep this thing going. I toss them out as noise because I care about cognition, and
okay.
You know, there are you know, I know there are other people out there who want to know, you know, how the brain maintains itself as a radio, but I want to know how the song gets played. So I don't know. I was just curious how you would respond to that.
Okay, so that I have a response to, because then I would say, okay, you can't do this division of labor, because if you're interested in cognition and understanding how cognition is implemented in the brain, you need to know these non-cognitive functions as constraints. So that was this example with the gain control. Like we want to know the specific firing rates that support information processing, or under which specific conditions gamma oscillations provide the system with an advantage in information processing, if they do. And so we need this gain control mechanism as a constraint to find that out and not posit some sort of implausible model, cognitive model of how this function is implemented. So even if you care about cognition, you can simply put it aside to others, because those non-cognitive functions will provide important constraints. Another case in point would be to look at metabolic constraints, right? Like how much energy has the system at its disposal, and ask whether the cognitive processes that I'm positing and the way in which they are implemented by neural firing rates, whether that's energetically plausible. And so it's because of these plausibilities that we need the non-cognitive functions, and we can't simply ignore them by dividing the epistemic labor in this way.
That's great.
Okay.
Yeah, I actually wanted to ask exactly the question that Joe just asked. And Philip, I thought your second answer was quite good, and I thought the talk in general was quite informative and very well put together. I have another question though. So I was interested in your comments about evolution, and you made another comment that the distinction between cognitive and non-cognitive functions is a matter of degree, perhaps not a black and white distinction. And I think that is probably right. Like I don't know much about swimming, but I seem to remember that in jellyfish, you've got just pretty simple organism that has neurons. It doesn't get a whole lot simpler. You've got some kind of like light sensitive eye cells, which sort of hook up directly to a pacemaker. And pacemaker cells you classed as non-cognitive, and then that goes right into some sort of rhythmic motor output. So that seemed like maybe a case that's a nice blend of cognitive and non-cognitive, because the modulation of that motor output can help the jellyfish avoid predators and all kinds of stuff like that, which seems like maybe not. I don't know if cognitive is the right word, but it's definitely somehow to do with information processing and judgment, decision making, that kind of thing. So I was just thinking about that case, and now let me make sort of a bold claim and just see if you would agree with it, that the distinction between cognitive and non-cognitive functions has sort of emerged slowly over evolutionary time, and only in sort of more complex brains is it a distinction that sort of really needs to inform research.
That's definitely thanks, Charles. That's a very interesting question. I also like this case, and I think that it's directly connected to this picture of evolution, or this sort of model of evolution that I alluded to, with this concept of encephalization. So I don't know if you read this book by Rodolfo Linas, Eye of the Vortex. So he introduces this idea of encephalization. So he claims that during evolution, motor systems get internalized. So you start basically just with organisms that just generate output, and then over time, input is actually added, and then you get something like an input-output information processing function, or what have you. And
what was the book called?
It's called Eye of the Vortex, From Neurons to Self, and Linas, L-L-I-N-A-S.
Okay.
And so he makes exactly that claim, and that's sort of what I also relied on when I used this concept of encephalization, that you could think about this, that perhaps evolutionarily you start with these pacemaking output units, and then later on you add input to that, and then you get this sort of information processing function. On the other hand, one needs to look more carefully, I think, into all the central pattern generator research, because they often work on very, evolutionarily old systems. And it seems to me that it's interesting. I think they have sort of thought about that when sensory input comes in, like, very hard, and it's a longer story to tell, that whole history which I also looked at. That's one thing. So in that sense, I'm sympathetic to your bold claim. But I think one also needs to be careful. There is also a very good paper by Peter Godfrey Smith and two evolutionary biologists that look at the evolution of the nervous system and argue that there are...
Oh, yeah, I know that paper.
Yeah, you know that paper. And so they sort of argue, well, it's kind of like if you decide for this either output first view or like sensory input first view, you will never get the story straight, because you kind of have to have an overarching framework to understand how the CNS involved. And I can see, like, I also am sympathetic to that claim, but I don't have the evolutionary story here is more like an additional support so far. I don't have like a very strong argument there, or haven't looked at it into these debates like quite deeply. But in general, like the way you're construing it, it's sort of roughly the model I'm working with as well, that you get that. At the same time, if it's true that these infrastructural functions that I talked about are count also as non-cognitive, then you have, even in human cortex or in cortex in general, you have non-cognitive functions underlying even, let's say, the highest evolved cognitive functions, because you need it again to regulate, for the system not to break down. So in a sense, it's still, let's say, dragged along or still needed all the way up.
Now we give the word to Daniel Rojas Libano. I hope it's correct.
Yeah, that's good. Can you guys hear me?
Yes.
Yes? Okay, great. So this is a great work. I find it very interesting. And
Thank you.
I have just one question. My audio system wasn't working properly during one of the questions, so I apologize in advance if I'm going over something already addressed. But so I think I concur with you that that we need to bring in what you call non-cognitive functions to this picture. But I'm worried that they might not be in the phenomenon. They might not be as separate as we think, maybe. For instance, some classical physiological functions, such as breathing, some people have started to show now that they might be playing a sort of master clock role in terms of the oscillations, and they might be providing a common time framework in which the cognitive operations occur across brain areas as a sort of temporal glue or something of this sort. We know that in the case of glial cells, we know that we started thinking about them as just a mere housekeeping cells, and now we know that it's much more complex. And so, and on the other side, if you consider information processing as a sort of computation that we can quantify based on the cell's activity, we can also sort of compute how many information the cell is processing, even if it's a circuit with a just physiological quote function, right? So I'm wondering, what would you think about this? So maybe we need to bring those non-cognitive functions, but maybe in the phenomenon, they're just the brain dealing with everything at the same time, or something of this sort. And yeah, that's
sure. Okay. I think those are like, so let me start with the general picture and then go to, I think there are like sort of three parts to your question. So the general picture, of course, I agree with you that we know that in the brain, it's a complex causal system, so all these things interact. So that's definitely true. The task for us as researchers, of course, is to try and first decompose the brain into some components and operations and see how they bring forth a certain function that we're interested in. So that's the first part, decomposition. And then I think the second part that I also mentioned in the paper is recomposing these decomposed functions together to look at how they interact. And that sort of recomposing step is exactly where I think your point comes in, where you look at these interaction between what I now call cognitive and non-cognitive functions. And of course, I already broke it down, right, into these more specific categories like subsistence functions and so on. So, for instance, with the breathing, you mentioned this master clock role of potential role of breathing. So, in the paper, I discussed this case where you have this whisking central pattern generator circuit.
Yeah, exactly.
And then there is this paper where they argue, well, we see that there is some sort of like correlation with the breathing rhythm that may suggest that breathing sort of is the pacemaker for all these facial behaviors. And I think that still fits sort of into this picture that I've sketched, because I would say, well, that just shows that there are these constraints on information processing by these subsistence functions. And of course, I'm perfectly happy to allow that they are not just these very general background conditions, or what I call enabling conditions, but they have these more modulatory roles. So that fits very nicely with this gradual notion. But I think in order to do that, we first have to recognize that there is this sort of spectrum, and that not everything in the brain is involved in the same way in cognition. And then we can look at how these interactions work and figure out better how the system works as well. And so I think that would also sort of hold for the glial cells. So of course it's super exciting to see that glial cells have like all kinds of different functions and not only, you know, maintain status quo. But then again, I think this, what I sketched is a sort of framework to look at the causal specificity of these interactions and then say how we describe them. And sort of with the third point, so you said, if I understand you correctly, you say, well, you know, even if it's the case that to the internal to the circuit, Gesundheit, if it's internal to the circuit, we can quantify the information. Yes, of course, you can apply the concept of information also to non-cognitive functions. I just made this sort of terminological decision to talk about information processing in the context of processing signals from the environment, and then when talking about these internal circuits, talking about maintenance and repair. I guess still the point would hold if you look at this research of chandelier cells, for instance, that their receptive field properties are quite imprecise. So they don't provide very precise representations of what these sensory circuits in which they are housed are processing. So the way they are connected in the circuit gives them quite low information processing capacity. And again, that's sort of, I think, all I need for this claim that, you know, they're not involved in the same way in information processing as these circuit elements that are operative in cognitive function.
Yeah, well, many thanks. So you think then that this cognitive, non-cognitive, then it's a matter of degree.
Exactly. I think that we already discussed that before. I just started sort of, I should have made it perhaps a bit more clear in the beginning, but I started with these sort of more of the poles of these two poles to see, okay, here's a very clear example where something, you know, plays a quite direct role in cognition, and here's an example where it's more this like background. And then of course we can think up all kinds of examples in between, and that's sort of what I would, you know, encourage sort of further philosophical and neuroscientific research to do, to sort of consider this whole spectrum.
Many thanks. Very interesting work.
Thank you, Daniel.
Thank you, Daniel. Now it's time for Jorge Morales, I hope I pronounced it correctly, to speak his question. Welcome, Jorge.
Yeah. Hi, can you hear me?
Yes.
Good. Hi, Philip. Thank you. Great paper. I have a comment and a question. The comment is in relation to Joseph McCaffrey's question about whether there is something, an example in which a function that is not cognitive have been confused or taken to be cognitive. And I'm not sure if it will take these as cognitive, but I think for a long time, researchers in the consciousness area thought that gamma oscillations were heavily related to conscious awareness of visual stimuli. They thought they were the neural correlates of consciousness, not just of general state consciousness, but of particular content. So some correlation with processing of information was taking place there according to that view. And now, of course, we know that that's gamma oscillations are neither necessary nor sufficient, maybe because of some of the things that you mentioned were oscillations, maybe in the gamma range, have to do more with gain control and other physiological things that are non-related to cognition. So that's just one comment. And my question might rehearse some of the points that have been raised before, but I think I agree a lot with what you say about the functions that have to do with maintaining the system. But I was wondering if, like maintaining and repairing, like gate control. But I'm wondering, I mean, you've mentioned the fact that it's not a black and white thing, that the cognition is a matter of degrees. But in the paper, you say something like, of course, cognition can affect sustaining mechanisms like breathing. Yeah. Like you see something scary, your breath, your respiration is going to increase frequency and something like that. Right. But I think that philosophers and psychologists of embodied cognition who sympathize with embodied cognition will be both very thankful with your approach, but at the same time maybe a little bit frustrated by the fact that the way you presented it was like one-way direction, where cognition might affect breathing or God's, I don't know, movements or reactions or whatever, whereas the upward direction, if you like the direction from the body to cognition is only like, it's only a mediation, it's only a condition in which cognition takes place, it's only like enabling conditions happen, whereas the view there, it's like, no, this is part, like an essential part of cognition, like we cannot split these two. So I'm wondering, what would you say to these more, like, I don't know, stronger challenge maybe from an embodied cognition philosopher?
Right.
Not, by the way, but you know. Yeah.
Thanks, Jorge. So to your comment, it's actually interesting that you mentioned that, because I looked into the history of this gamma research quite a bit, and it's definitely the case that it's always been controversial, whether it has like this cognitive role or role in consciousness, and there's like pro camps and contra camps. And a paper I can recommend on this is by Björn Merker, Merker, and it's called Gamma Oscillations, the Functional Key is Activation, Not Cognition. And in that paper, he makes sort of the strongest case for that gamma does not have this cognitive role, but is always occurring during cognitive processing, because it has this indicating role, right? Like it indicates the circuit activity level, but it's not specific to any of these things. And I agree with that, but I think he goes overboard with the argument of saying that if it has an infrastructural role, it cannot have any cognitive role. And I think that's simply not true, because if you then again look into this synchrony literature, the view today is, by this coherence, communication through coherence hypothesis, is that gamma provides an information processing advantage because it increases the rate of transmission between two areas, right? So if V1 and V4 oscillate in the same range, then there is like faster information travel. And that sort of feed-forward role is perfectly consistent with this feedback role for the local circuit. And so my position is that we simply need both. We shouldn't say, well, if it has a non-cognitive role, it can't have a cognitive role, because that's also part of multifunctionality, that it could subserve both at the same time, right? Or in different sort of systems. So if we make the containing system small as a circuit, you see this infrastructural role, and then if you make it big, then to the system level, then you see this cognitive role. So again, I think that although it's true that I think the cognitive interpretation of gamma oscillation historically has been exaggerated, and now people sort of have become more cautious, we shouldn't go to the other extreme and just throw the cognitive role completely out the window. That would also be a mistake. Now to your question, which, by the way, I think is also very, very cool, very interesting. So yes, you're right. One shouldn't stop at maintenance. I agree with that. So for instance, you could look into, which I haven't done yet, you could look into all these like allostatic processes, right? So those are like physiological processes that are activated to bring the body back to homeostasis, but they're much more active. So they're might be hormonal processes and stuff like that. And so that's in itself some sort of internal signaling that goes beyond just this maintenance. So definitely agree with that. And I think my working hypothesis is that those will be these sort of modulatory functions in between operative and enabling conditions, because they will affect many different types of cognitive tasks. With regard to the embodied cognition literature, I, as a philosopher of neuroscience and practice, I sort of use more the neuroscientist perspective on working on these functions, which from this philosophy of mind point of view, you could of course criticize as quite brain-centric, definitely, right? Because they look for an area or a network and its role in cognition, and they never talk, or oftentimes don't talk about the body. They also don't have the research tools to do that because the technologies oftentimes don't allow that, so on. And so in that sense, I am talking more about, neuroscientists should, regardless of whether or not you are an embodied cognition person, you should look at, even if you just look at the brain, if you want to understand cognitive functions in the brain or the parts of cognition that are in the brain, you need to understand these non-cognitive functions. So in a sense, my claim is sort of orthogonal to the embodied cognition claim. So it could be true that it's all brain-centric. Then I would say, well, still you need the non-cognitive functions. Or it could be, which I'm very sympathetic to, but I don't have the expertise to say a lot about, could be that that other parts of the body are constitutive parts of the cognitive system, and then it's still the case that there's this maintenance going on. And I think what you said with this other direction, we would need, I am sympathetic to this other direction, but what I am often frustrated with the embodied cognition literature is that we need a better account of how exactly these bodily processes then shape the cognitive outputs, right? Rather than just saying, oh, without it, it's not possible or something like that. It would be way better if they show that it has some sort of more specific effect. At least in my framework, that would make better evidence that these other parts or processes in the body or even in the environment are operative in the cognitive processes, that they have various, you modulate parts of the environment or you modulate parts of the body and you get these really distinct effects. And so if it would show that, then that would be really cool.
Great. Yeah. Thanks for the answers. Very insightful. Maybe okay. I'll just add that with respect to the last point, I think we don't need to go embodied cognition in terms of that kind of literature that is closer to social psychology. But I was thinking actually about neuroscientists working on neuroscientists like Micah Allen, for example, in UCLA. Right. He has very cool experiments with heart rate and respiration and how they relate to metacognition in a way that, tries to address the neural mechanisms of what you were hinting at. It's how exactly are these things affecting cognition? And I think that at some point, the entanglement between what is cognitive and non-cognitive, as some other participants have pointed out, becomes murkier. It will maybe breathing, of course, and neural the neural correlates of breathing are performing a sustaining function, but at the same time they might be performing a cognitive function that it's not just enabling, but it's a fundamental part of the processing of information. Of course. Or rhythms of respiration or heart rate or things like that. Yeah.
Thanks, and I think that's why I said at the end that this model that I presented, right? It's not this is a working model. So if this is what you said, that you can look at Micah Allen's experiment and try to see how that fits into this model. Maybe you have to revise the model. That would be exactly the point. So I'm all for that. I think as philosophers, we should way more have this future-oriented perspective to sort of engage with further research and then make our models empirically revisable. So this what I presented there should be able to incorporate these results and then see whether that changes some of the accounts. So I'm all for that. I wouldn't say, oh no, but that can't be because my account is like that and that doesn't fit into my account. I think it's actually the other way around. So thanks for this example. I will look into that more closely.
Cool. Thank you.
Thank you.
Hello, Philip. Thank you for the talk, and your paper was really interesting. I just have a comment, actually, and I'm in favor of your approach. My comment is actually more from a perspective of philosophy of science. So, in the methodological sense, like in a broader context, your patchwork approach is good because it is like, if I could parallel with it, like a healthy pluralism, yeah? So it's open, it's not exclusive, so it's like a organicistic view, yeah? Because the focus is on the possible symbiosis of subsystems which are not in the focus with the cognitive myopic view, yeah? So that is partially why I agree, because it looks at the whole nervous system or CNS or the brain or parts of its subsystems with respect of its unknown functional and structural complexion. And secondly, which actually is implied by the first, is, as you said, it's like a revisable model, so it's not exclusive, and so we have actually theoretically better chances of broadening our knowledge on the given topic. So thank you.
Thank you, Borian. I definitely, I'm in favor of pluralism too. Although, of course, there's different kinds of pluralism, and I haven't situated myself in this literature yet. But definitely, I would say it has an element of pluralism because it says, well, you know, you have to keep your concepts sort of internally heterogeneous if you're dealing with these complex systems that have sort of different kinds of properties. And yeah, if you're interested in that, I can recommend, of course, Mark Wilson's book, which is a big book, but it's very insightful about patchwork concepts in physics and mathematics. But also, there's some papers by Alan Love and Julia Burston on the patchwork structure of evolutionary theory and patchwork structure of chemical kind concepts. So if you're interested, those would be good readings.
All right, thank you. And well, if I could go a little bit further, I would say that it rings a bell of how you speak of it methodologically with what was said once by Feyerabend when he was talking about his principle of proliferation of many, as much as possible, and different approaches in science. Yeah, because we have this model which is modelable, remodelable, so to speak, conceptually and then methodologically as well. So that would be another aspect, perhaps.
Thanks. Yeah, I think that I haven't looked into like Feyerabend, I must admit. So I mean, I know the general position, but not the details of the view. But Hadok Chang in recent years has articulated a version of pluralism that sounds much like that, where he says he looks at this case of chemical research on water, and he says that this oxygen, like water and oxygen and so on. And then he says that the sort of phlogiston theory was abandoned too quickly, and some of their epistemic insights got lost. And then what we call classical chemistry took like 100 years to recover these insights. And he says if you would have let these systems of practice run at the same time for a while, you would have gotten perhaps to some of the insights much quicker. And so in a sense, you could say, yeah, definitely, if, you know, like I'm totally fine if people want to just work on cognitive functions, that's also, of course, very important. If you would have this parallel research on other functions, and then there would be a fruitful interaction, I think that would definitely bring our understanding, or hopefully bring our understanding of the brain forward.
Yes, I completely agree. Thank you.
Thanks, Bojan. Thank you.
No more questions? In that case, I have a very silly and very brief terminological question. It is about the paper itself. At page 3, I was puzzled because you define non-cognitive functions as neural entities and activities.
Yeah.
I was, when we speak about neural activities, I can see, Philip, why this might be a function, but why entities too? How might an entity that seems to be a three-dimensional object be a function? Was just a typo or what?
Yeah, thanks. I guess the better terminological way of putting it would be acting entities. So what I wanted to say is that, you know, like an activity obviously, if you have this sort of broadly mechanistic framework, then you usually have like a component, and the component does something. And I guess what I wanted to say is that the neural functions are what these entities do, or like a set of entities, right, do. And so you're right, the better way of putting it is like the and should be like it's always both, not either of them. But I think perhaps it's less ambiguous if I just put acting entities or something like that.
Thank you, Philip. Just a brief follow-up. You've already answered to this question, but it's again related to the causal specificity as a criteria to distinguish cognitive and non-cognitive structure or functions. Mm-hmm. Maybe if you think at one of the best example of a non-cognitive function is thirst, so the neural circuits that control homeostatic fluids such as water, the quantity of water, and there is now the circuit that control thirst and homeostatic fluids is well known. There is a very interesting review, natural review by I don't remember the names. And of course, if you damage this, you have dehydration, so the lack of fluid. And there are many research showing that dehydration is connected to cognitive impairments such as attention and memory. But this effect it seems to be at least a bit graded in the sense that there are some distinction between severe dehydration, mild dehydration, and moderate, and there are some studies showing that there is a graded effect on reaction times in both. And you seems to recognize this in your paper when you say that, of course, that there could be the non-cognitive, the sustaining function can be graded, but that there is you introduced the other criteria that we already discussed that is specific in the sense that it affects only one cognitive function. But this is something that may be done, as already said, if you take a cognitive structure such as angular gyros that is involved in many cognitive functions such as reasoning, visual imagery, and language, and so on. And clearly, maybe the best example of cognitive structures are not specific in this sense. But this is something that maybe you've already answered.
I mean, thanks for the example anyway, because that's like one of these examples that I mentioned like very generally, but I think it's really worth of understanding from what you just said, it's worth of taking that as another case, as a case study of looking at how to disentangle or at least distinguish these cognitive, non-cognitive functions or structures, or the non-cognitive functions of and cognitive functions of a structure, right? Because I don't think that there's any. Like maybe there are some purely non-cognitive functions, like the lobster gut digestion thing or something like that, but that's probably quite rare. So I think again, I think you already mentioned what sort of my answer would be, that even though there might be this graded effect of dehydration, it will affect more than just one function. And so I think that's another aspect of how it can be non-specific. And it would be, I think, so Carl Craver has, I think, an example in his book with hunger and the hypothalamus, right? And so it's like the hypothalamus like indirectly interferes, like manipulating the hypothalamus indirectly interferes with many different things. And so it's these, and it's interesting, of course, because I need to think more deeply, I think, about this question, because these hub regions, of course, would have the same property, right? Because by virtue of their connectivity, they will always have these spread effects, but all of these effects might be sort of cognitive. And then the question is manipulating, like what does, maybe we have to go in more detail what the manipulation actually does. So you could think about, like, if you have a hub, right, and it has like 3 edges, it could be that manipulation 1 activates like this edge, manipulation 2 activates this edge, and manipulation 3 this edge. That could be that it's multifunctional, but still sort of specific in a sense that there's manipulations that map onto how these edges are involved. And then perhaps if you have sort of, let's say now we have the first structure, we also have these edges, but it's more like manipulation 1 affects like edge 2 and 3, and then 1 and 3 or something like that. So that it's not like this one-to-one thing, but that's again just now off the cuff sort of construal, and I think it's good to go into more detail with that idea. Thanks.